we're going to talk about oxidizers and reducers, and oxidizing agents and reducing agents. Okay. So an oxidizer or an oxidizing agent is something that is an agent that helps something else oxidize. It itself is undergoing reduction, and it does that by accepting the electrons. Reducers gain, something that's reducing gains electrons, and in doing so accepts them from the agent that is oxidizing or losing them. And of course the reverse would be true. Reducers or reducing agents are those that are actually undergoing oxidation, and in the process of losing electrons they are allowing another substance to gain them. So if we take sodium chloride, for instance, the formation of it, that's an obvious redox reaction. And if we look at the chloride, okay, so this chlorine is gaining electrons, so we normally would say that's reduced, and that the sodium is losing electrons, so that is oxidized. But in the chlorine, by gaining electrons, it has to get electrons from somewhere, and it gets them from the sodium. So the sodium is acting as the reducing agent. And in order for the sodium to donate electrons, it's got someplace it's got to send them to, and that would be to the chlorine. So the chlorine is helping the sodium to oxidize. So it is the oxidizing agent. Okay. So if we look at the standard reduction potential table, we said the things at the top are most likely to reduce, and the things at the bottom are most likely to oxidize. And of course, when they're oxidizing, the reaction goes the opposite way. So the things that are oxidizing are the strongest reducing agents, and the reducers, the things that are reducing, are the strongest oxidizing agents. Okay? So that's pretty much the way it works. And the greater the distance between them, the greater the oxidizer or the reducing agent. Okay? So reducing agents, the word agent was actually taken out of the curriculum this year, but I did notice that they are using the term reducer on the AP exam. So let's have a look at what that question looks like. So it says chromium is used to reduce other compounds in a chemical reaction. If a chemist needs a substance that is more effective in its reducing ability, which of the following would be the best choice? So it's a substance used to reduce other compounds, which means it is being oxidized, right? It's being oxidized. Okay, so metals go to their metal ions when they lose electrons, right? So metals go this way, ions go the other way, right? So this would be a reduction, and this would be an oxidation. So if it is something that's going to help something else reduce, it is something that's going to oxidize. So because the top of the table, the more positive standard reduction potential is at the top, because it's reducing, those are going to be strong oxidizing agent. Okay, and at the bottom of the table, they are going to go this way, and they are going to be oxidizing, and therefore they are strong reducing agents. So the stronger reducing agents are at the bottom of the table. Now be careful here, because we have potassium. So hydrogen is in the middle, right? Let's just identify where we are. Hydrogen's in the middle. Chlorine's way up here. It's going to reduce, so it's going to be a strong oxidizer or oxidizing agent. And then we have potassium down here, and we have zinc, the other two choices. Now the potassium is the metal, and the potassium is listed as the ion, and the zinc is listed as, where's the zinc? Is listed at the metal. Okay? So if this is itself oxidizing, it's going to be a reducing agent. So that is a possibility, and it is a stronger reducer than chromium because it is below it. Okay. Now the potassium, we're not talking about K. We're talking about K plus. So the K is going to go the opposite way. So K plus is not a good choice. If K were here, that would be the best choice, but it's not. Okay. So the answer is going to be A, zinc.